Hello, we're going on to a new topic now, which is area. So in our complete topic, we're going to be learning the following things. We're going to understand what area is. We're going to be able to calculate area by counting squares. We're going to find the area of squares and rectangles using a formula. Find the area of composite shapes, which use squares and rectangles. So they are shapes that are made up of putting squares and rectangles together. Then we're going on to areas of triangles, areas of composite shapes with sloping sides, so that's combining triangles and squares and rectangles, and then finding missing lengths using area information. So it's quite a lot there. It's going to take us a couple of weeks. And first of all, what I want us to think about is the following things. First of all, before we get started on our topic of area, what do we mean by area? If somebody said, I don't know what you're talking about when you mention area, how would you explain it to them? I would also like you to think about why we would want to calculate area. Why is it even a thing? Why is it even something that we bother to teach and learn? And think about jobs and daily life and think, who needs to know how to calculate area? So if you're in class, pause the video just now. If you're at home and you've got somebody nearby to talk to, you could discuss it with them, or you could just have a think. But come back in a minute anyway. So area is to do with flat shapes, okay? Two-dimensional shapes, shapes that we could cut out of paper or cardboard, okay? And the area of a shape is the amount of space it takes up, either on a page or on the floor or on the wall, just a flat shape and how much space it takes up, okay? So if you think about doing perimeter, so I'm just going to draw here a little bit. Remember, perimeter is the distance around the outside of a shape, so that would be the total length of these blue lines. So if we wanted to know the area of this shape, what we'd have to be working out is the amount of space inside the perimeter. Okay, so perimeter is a length. Okay, it's the total length of the outline of a shape, but area is the inside bit, it's what is inside the perimeter. Okay, so why would we want to calculate area? And who needs to know how to calculate area? Well, there are lots of things, particularly to do with your home, that require an area calculation. So, for example, laying turf in your garden. You would need to know the area of turf that you needed to cover. If you were doing another project in the garden where you needed to cover with slabs or chips, and you would need to know the area that you would want to cover to make sure you can budget correctly and buy the correct amount. Inside the house, if you're painting a room or if you were wallpaper in a room, you would need to know what area you had to cover on your walls. Well, I've just been out to the garage and got a tin of paint and taken a photograph of it. So there we go. Here's our picture of our tin of paint. I wonder if you can see there. Let me move this up a bit. Move the picture down. There we go. I wonder if you can see here on the outside of the tin of paint. It says up to 32 square metres, or M2. That means square metres. We'll come on to that in a little while. So it tells you that this can of paint will cover up to 32 square metres. So we need to know what the area of the walls, the total area of the walls is, if we're going to buy the right amount of paint. If you're fitting carpet in a room, you will need to know the area of the floor, or if you're fitting laminate or tiles, you would need to know the area of the floor. So there are lots of household reasons, particularly decorating and home improvement reasons, why you would need to know the area of a shape. Okay, and remember, area is of flat shapes, things like walls, floors, that kind of thing. So the short answer to who needs to know how to calculate area is really all of us, but particularly if you work in a job that is to do with flat surfaces. So what we're going to go on to now is finding areas of shapes on squared paper. Because when we're measuring area, we have to have units. So if we just skip back to the last page, when we were thinking about perimeter, we were using units of length. So that would be things like meters, centimetres, millimetres, kilometres. Okay, when we find area of shapes, we're using square units usually. Okay, so here we've got a picture. So this is a picture of just squared paper like you've got in your normal maths book, and showing you different areas compared to their associated lengths. So first of all, we can see here, I've just drawn a line that's 1 centimetre, so you can see that in your book. Okay, if you turn that line into a square that's got a centimetre all the way around, that completes 1 square, doesn't it, in your book? And that square, the size of it, the area of it, is 1 cm2. Now, we don't say cm2, we say square centimetre. Okay, so cm with a little 2 up there means square centimetre. So cm for centimetre, and we know that squared is when we put this 2 high up at the side. Okay, so this is the size of 1 square centimetre. So if we draw a line now that's 2 centimetres long, if we make that into 2 boxes, so basically we've got one box that's the same size as the one that we just shaded a moment ago, and we've got the other box. So the area of that shape is 2 square centimetres. But don't forget, that area is not 2 centimetres by 2 centimetres, it's only 2 centimetres by 1 centimetre, so that just completes 2 boxes. Okay, if we did 2 centimetres and 2 centimetres for the sides of our square, we can see that we would have 4 boxes there, wouldn't we? We've got that one up there, this one down here, and this one here. So if we go 2 by 2, then our area is 4 square centimetres. Let's go to that so you can still see it properly. Okay, so let's have a look at some bigger rectangles to start with. So what we're looking at is basically how many squares are in each rectangle. So if you want to pause the video just now, and you can have a quick count up. So each shape, so this one, and this one, I want you to find the area. In other words, tell me how many square centimetres each of these rectangles takes up. So you're counting the small squares in each one. So pause the video while you do that. Okay, let's see what we've got for our areas then. So for the 6 by 2 rectangle here, when we count up all those squares, we count up to 12 square centimetres. Okay. This one at the side, the 4 by 3 centimetres one, again, that's got an area of 12 square centimetres. So these two shapes both have the same area as each other. They take up the same amount of space on the page, although they are different shapes. Okay, and then this one, if we count the squares there, we've got 21 square centimetres. Okay, so we can find areas by counting squares. Okay, we're going to go on and look at some more tricky shapes now. So what I would like you to do, once I've shown you one example of each, is pause the video and have another look at this yourself. Okay, so for the triangles, we can see that we've got complete squares, but we've also got squares that are chopped in 2. Okay, so that square's been chopped in 2, and that square's been chopped in 2, and so has that one. So when we count them all, we count the whole ones first. So we've got 1, 2, 3 whole squares, and then we've got a half a one. And if we put that half a one together with that half a one, it makes a whole one. So that's 4 altogether. And we've still got a little half left there. So we've got 4.5 square centimetres. And remember from work on decimals that 4.5 can be written 4.5 square centimetres. Okay, so that's finding the areas of the triangles. So if you pause the video just now and find the areas of this triangle and this triangle and this one. When you're doing this triangle, you've only got half triangles to work out. But when you get onto this one and this one, you're going to have to try and make whole squares. Okay, so I'll leave you to that for a minute. So pause the video, then come back. Okay, so let's look at this biggest triangle first of all then, when we're finding the area. So I'm just going to put a dot inside the squares where that we've counted. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 there. So I'm going to write 15 at the side. Oops, that was a bit thick. Just a minute. Let's put it back down to that. So that one was 15. Okay. And then we're going to look at these half squares. So I'm going to put a dot in the half squares as well, so that we can see that we've counted them. Okay. So if we put two halves together, remember they're going to make a whole one, aren't they? So you've got these two make a whole one. So that's one whole one. 2 whole ones. 3 whole ones. So we can add 3 to our 15, and that gives us 18 square centimetres for this big triangle here. So I'll write that at the top, 18 square centimetres. Okay, now we're on to the more tricky ones. So first one, again, I'm just going to put a dot in the whole squares. Well, we've only got 2 whole squares there, haven't we? But if we have a look at the incomplete squares, this bit here is exactly the same as that bit there. So we can add the bit that I've just shaded in up there to the bit here, the part of the square there, and that makes a complete square. And we've got the same here, that bit and that bit make a complete square. So what we've got is 1, 2, 3, 4 complete squares there. So 4 square centimetres. And onto the last triangle, which again is a little bit more tricky. So we'll do our full squares first of all. Go a bit thicker with my pen. So 1, 2, 3, 4, 5, 6. So we've only got 6 full squares in there. So now it's going to be a little bit of a tricky job trying to work out which bits we can put together to make the complete squares. So I wonder what you thought to that. So what you might have noticed is that this part of square here, if you match it up with that part of the square there, you get a whole square. So I'm going to write the 1 there. If you match this big bit of square here with this tiny little bit of square there, you get another one. This big bit matches with that one to make another one. And that bit matches with that one to make another one. So what we've got all together there is 6 and 4 ones makes 10 altogether. But that one was a little bit more tricky. So if you got around about 10, well done, because that was not so straightforward. Okay. When we get a little bit further on in our topic of area though, we're going to be able to calculate areas of triangles exactly, and we won't need to count squares. Okay. Now, last 2, we've got these blobby shapes now, and these are definitely a case of estimating. Okay, so I'll leave you for a couple of minutes whilst you have a look at these shapes. See if you can count squares, count whole squares, and see if you can put bits of squares together to make whole ones. See what you think, and then come back. So you can see that these ones with curvy edges that are not regular shapes, they're a lot harder to work out, aren't they? So if you got in the area of 17 square centimetres for this one, and round about 9.5 square centimetres for that one, then you've done really, really well with that. Okay, now that's the only time that we're going to be looking at finding areas of shapes where you're having to estimate, where you're putting things together and using a little bit of guesswork to some extent. Because now we're going on back onto regular shapes. Okay, so what we can see here in area and volume exercise 1A, so if you're at home and have been working at home and getting sheets sent home, you'll have this at home with you, or you can just do it straight from the video. So if you pause the video, and I just want you to find the number of squares in each of the following to find the area of the rectangles. Each square is 1 square centimetre. So basically, you're just counting squares. So pause the video just now and find the areas of those rectangles. Remember, we need our units of square centimetres. And here are the answers. So you can pause the video and check those. And then I've got a couple of things that I want you to work on. Okay, so the first one is, it's really up to you whether you do this one. For people who like doing this kind of thing, then you could do it with more than one blob. If you really did not enjoy that last exercise where we were counting the squares and having to put bits together to make whole ones, then it's okay. I think you've probably already done enough practice. But if you like doing that, then just draw yourself any sort of a blob on squared paper and try and estimate its area by counting squares and putting bits of squares together to make whole ones. And then I have got a challenge for you to think about. A family has a rectangular garden which is 6 metres by 4 metres. So I've given you a picture of this rectangular garden. So first of all, I want to know what is the area of the garden. Okay, now you've got to remember that the garden is 6 metres by 4 metres. It isn't 6 centimetres by 4 centimetres. So what that means is each one of these squares here is equal to 1 square metre, not a square centimetre. So when you find the area of the garden by working out how many squares are in here, then your answer is going to be a number of square metres. Okay, so that's your first job. The second job is to work out how can the area of the garden be divided equally between the 4 children in the family. I want you to use only straight lines and to draw your answers. Okay, so I want you to draw the rectangle that is 6 metres by 4 metres in your book or on squared paper. And I want you to see how you can split it equally into 4 parts. So you're going to have to work out how many square metres need to be in each of the 4 parts, and I want you to find ways of doing that with straight lines. Now, I'm saying with straight lines, but just so we're clear, the straight lines can go diagonally. Okay. The straight lines can go like that. Okay, as long as the lines are straight, what I'm saying is I don't want anybody dividing the garden up like this. Okay, so only straight lines, please. So that is going to take you a few minutes to do. So if you pause the video and have a go at that. And if you're not sure, if you need a bit more explanation, it's not a problem. Just pop back into your lesson and let your teacher know. Okay, so I'll see you soon and find out what sort of answers you've got. Okay, so in a slight change to usual, I'm not giving you the answers this time, okay? I'm not giving you the opportunity to fast forward the video to see what the answers are, because there would be lots of different answers, okay? So what I would like you to do is, when you've done this, I want you to pop back into the lesson, because this was the last task in today's lesson. So if you pop back to the lesson just in a minute, when I've finished off here, then I want you to share with the rest of the class and with your teacher what it is you've done. What are the different ways that you've divided your garden up? And I want you all to have found several ways of doing it each. Try and find some ways that you think nobody else will have got. Okay? And then once you've done that, we just want to recap how we're doing with our learning outcomes. So hopefully now we understand what area is, and we can calculate area by counting squares. That's as far as we've got today, and we're going to go on next lesson to finding the area of squares and rectangles using a formula. So you hop back to the lesson when you've finished your dividing up your field or your garden, and you'll be able to see what other people have done as well. So I'll see you soon.